Hi everyone, it's Sorkan. Today we have a problem when we are given an array nums which represents the amount of money at each house. So for example, let's say in this case at house A we have amount of money 1, at house B we have amount of money 2, and so on. So what we need to do is we have a robber that rob houses, and the robber cannot rob two adjacent houses because they have alarm in place. What we need to do is we need to return maximum amount of money that robber can make. So for example, in this case we are going to use dynamic programming bottom-up approach. Let's remind ourselves what is dynamic programming bottom-up approach. It's an approach where we are splitting a problem to sub-problem. First we are solving the small sub-problem, then we are building up to our solution. So let's say that we have only one house. So what's the maximum amount that we can make if we have only one house? In that case, we are going to, the maximum amount that we can make is just whatever the value is there, right? 1. So we are going to create DP array with the size of our input nums where we are going to store our subproblems. So first, if the size is equals to 1, we are storing that value in our DP array in the 0 index. So if we have two houses, right? So if we have two houses, then what's the maximum amount that we can make? In that case, the maximum amount is 1 and the 2. 1 and the 2 is 2 because the 2 is more than 1, so we are comparing that whichever is maximum, and we are choosing that one as the value for if we have if the size of our input is 2. Let's say that so now we have 2, and now we have 2, and then let's say that we are adding one more. We are adding 3. So what's the choice? What's the choice that we can make in this case? Either. So again, we cannot take the two adjacent houses, right? In this case, we can take only either. So either, let's say that the 1 and the 3, right? 1 and 3, or we can take whatever the value is here. So what it means that we are either going to take whatever the maximum value here prior to our current index, which means that I minus 1, right? So this value, or we are going to take whatever the max value we had until this point, right? In this case, for the index 0, and plus whatever the value we have right now. So which means that the 2, we are taking either 2 or 1 plus 4, 1 plus 3 gives us 4. So it's a DP, right? For the DP, we are updating this value. We are taking the maximum, and the maximum in this case is 4, right? So now we are going to the next one. Again, the next one, we are making the same decision. The decision is that either we are taking whatever the max value was until here, right? Until B, because we cannot take two adjacent houses, right? So we are taking whatever the value was here at B plus whatever the current value that we have for nums, right? Or we are taking the previous value 4. So 1 plus 2 gives us 3, and 4, we are comparing 3 and 4. So the maximum of 3 and 4 is 4, so we are returning 4, and we are returning 4 as a result. So what's the time and space complexity of this solution? The time complexity is of n, because we are going over our array only once, and the space complexity is also of n because we are using DP array, which is the size of our nums. I also have identical solution in Java. I will include that in the description. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.